Okay, so we have the essential idea of momentum down in that it's a pretty simple equation where it's just a plug and chug mass times velocity, okay? So what we want to look at, and where momentum is actually more exciting, is when you actually look at the change that momentum undergoes. And that's what we want to look at, is how the change in momentum occurs, because that's actually the instant an object starts changing its motion, and that's what we want to look at. So when we discuss the change in momentum, it's literally exactly what it says. It is the final momentum minus the initial momentum. So P sub F stands for final momentum, and P sub I stands for initial momentum. And when we write this out fully, it's still this mass times velocity, okay? And what we look at, though, is, okay, what does its final velocity have versus what does its initial velocity have? And that is what change in momentum is. So one of the things that we want to do is think about what specifically must be done to an object to change its momentum. And for that, what we really need to do is look at the equation for changing momentum. And when we look at that equation, there's basically two things that we can do. In order to change momentum, we can, one, change the object's mass. Now, you have to think about that, and an object like a car traveling down the road, changing that object's mass isn't going to be the easiest thing to do, okay? Or any moving object that once it's moving, changing its mass is not going to be easy. But what is easy, well, or easier I should say, is actually changing the object's velocity. That is actually something that we can do just by applying an outside force to an object. So one of the things that we look at here is the mass of an object is usually fixed. What we're going to do is change the velocity. So if we have the mass of an object fixed, then our equation becomes the change in momentum is mass just times the change in velocity. Okay, so this we're going to keep fixed. And now you'll notice your units won't change any. You'll still have kilograms, meters per second. So just because we look at a change in velocity, that's not going to change our units. And then we would shorten this up to delta V if we wanted to, which is still our change in velocity. So then you got to think about, okay, if velocity is changing, what event is actually happening if our velocity is changing? And I hope you're thinking in your head, well, a change in velocity is acceleration. So acceleration is a change in velocity with respect to time. So if our velocity is changing, then we must have an acceleration going on. And now, what must we apply to actually produce an acceleration? And that, hopefully you're saying, is a force. Okay, so this whole idea of force in physics just never seems to go away. It's now in every single chapter that we've been dealing with. Okay, and so force is mass times acceleration, and just a review, if you increase force, you increase acceleration, and decrease force, you decrease acceleration. So since acceleration, is the change in velocity divided by time, we're going to do our favorite thing, which now is to substitute equations into other equations. And so this equation then becomes force equals mass times change in velocity with respect to time. Okay? Now, this equation is actually pretty unique. And so what we're going to do is we're going to manipulate this equation a little bit. And the first thing I'm going to do is just multiply both sides by the change in time. And that would obviously cancel that. So this side, I have force times the change in time equals mass times change in velocity. Well, here, ladies and gentlemen, is change in momentum. This side of the equation is what causes that change in momentum. I'm just going to say what causes the change in momentum P. So what we want to look at is this side of the equation right here. We want to look at this because that force times time is actually going to be what causes an object's velocity to change. So this force times delta T is actually something called impulse. Okay? And so if we look at this, force, or F, is still just our force, that is in newtons. The T, the time in this equation, is something new, and it's something that we haven't talked about. It's the time of contact of the force. And that is something that we've actually never said. We've been applying forces to objects all year long. We have never said one word about how long those forces have been applied. And now all of a sudden that's what we're going to do, is we are going to now determine how long those forces are applied. And as you might imagine, if you increase this time, that's going to increase that impulse, which then in turn increases our change in momentum. Okay? So there is an equation here and a new symbol where in this new symbol, this J stands for impulse. So there we have a new equation basically for impulse. We have this equation right here. And later on, I will actually put what do we need on our note cards. But the bottom line here is this impulse is equal to the change in momentum, which is a very short equation, but this is basically saying impulse equals, and I like to say causes actually, change in momentum. So if you think about this equation, when you apply a force for a certain amount of time to some mass, that's going to change its velocity. Okay, that's what that equation basically states. Before we move too far away, I do want to talk about the units of impulse. Okay, so if we look at the units of this, force is in newtons and time will be in seconds. So since this is force times time, this is going to be a Newton second. And one thing about a Newton second is that has to be equal to the units of change in momentum. The units of change in momentum are kilogram meters per second. So is this the same as that? And if you write out what a Newton is a kilogram meter per second squared times that second. So that would cancel that second and that second, which gives you your kilogram meter per second. So the units are the same. It's just a weird thing that when we talk about impulse, we always talk Newton seconds. So this was just a strange meme that I found as I was searching for some different stuff. So things to pull out of this is change in momentum is equal to force times the time that that force is applied. Okay? And so, again, something that I've already stated, but the force now is only applied for a certain amount of time. This is impulse. So let's look at an example. Oh, wait, before we do that, sorry, I told you I'd pause for our note card worthy equations. So right now, you should have this equation already on your note card. You just need to add these, and you can add this one as well. But you can pause the video to do that. Moving on. So here's an example. A ball with a mass of 0.68 kilograms is thrown against the wall with an initial speed of 10 meters per second and comes to rest. What is the impulse imparted by the wall? So here we have our wall, and we're going to throw a ball to the wall, and the ball stops. Okay, so the ball has an initial velocity of 10 meters per second, and then it has a final velocity of 0. It came to rest, and we know that it has a mass of 0.68 kilograms. Okay, so first of all, if you notice, the question says, what is the impulse? Well, the equation for impulse is force times time, and I don't have either of those. Okay, but impulse is also equal to mass times change in velocity. So you're going to have to look at what information you are actually given, because in this particular problem, I'm given the mass and the change in velocity. So I can actually calculate the impulse that way. So the impulse is equal to the change in momentum. I'm going to just write it like that. Oops, I'm sorry. I'm going to write it like this. The impulse is equal to the change in momentum. The change in momentum is mass times V final minus V initial. And so the mass is 0.68 kilograms, and V final is 0. V initial is 10. So the change in momentum, which is also the impulse, is 6.8 kilogram meters per second. And notice it is negative. Okay? So that's why this says, what is the impulse imparted by the wall? The wall is what's changing the object's motion. Okay? So the change in momentum is minus 6.8 kilogram meters per second. And again, those are numbers we're going to have to get used to, but we will, because, you know, what does this really mean? We'll learn as we go. Okay? Now, suppose the same ball, okay, so I have the ball that has a mass of 0.68 kilograms, the same ball, okay, is thrown against the wall. So here's my ball. It's going up against the wall, but it rebounds. So now this time we have a final velocity of 5 meters per second and an initial velocity of 10 meters per second. And we want to know what the impulse is now. Okay, something very important that we need to take care of, and that is direction. If this is positive 10 meters per second, then this going the other direction has to be negative 5 meters per second. That follows our sign convention we've been using all year, where everything to the right is positive, everything to the left is negative. So that means our final velocity has to be negative. And again, we have the equation for impulse of force times time, but we don't have either one of those. We just have to remember that impulse is also equal to change in momentum. So change in momentum is mass times v final minus v initial. And this is still pretty much plug and chug, 0.68 kilograms times v final, which is minus 5 minus v initial, which is 10. So this right here, ladies and gentlemen, is minus 15. And so that change in momentum turns out to be minus 10.2 Newton seconds. So one thing you'll notice in this, see if I can do this right the first time. Is that if the object stops, it has less momentum than if the object actually rebounds. Okay? So now, next question is, okay, let's assume the time of contact in each case is 0.3 seconds. So we're going to assume that the wall slows the ball down in 0.3 seconds in both cases. Okay? So I want to know what would be the force that's acting. So now we have an impulse in the first trial of negative 6.8 Newton seconds, and we have an impulse in the second problem of negative 10.2 Newton seconds. And we just want to find the force, and what we can remember is impulse is just force times time. So time is, excuse me, I want the force. Force is the impulse divided by the time. So over here, the force would be negative 6.8 Newton seconds divided by 0.3 newtons. Excuse me, nope, sorry, seconds. It's going to cancel out my seconds and give me newtons as my force. And then over here, my force is negative 10.2 Newton seconds divided by 0.3 seconds. And so in this first case, my force is minus 22.6 newtons. And in this second case, my force is minus 34 newtons. And so a little hidden secret here is for objects to actually bounce actually requires more force. So, something to keep in mind. So, kind of in review, here's where we're at. We started with this simple equation, which we can never just leave simple. So, impulses on objects change the object's momentum. So, the impulse causes the change, okay? So if a force is applied to an object for a certain amount of time, it's going to be the velocity of that object that changes. Remember, we're not going to change mass of a moving object. Yes, we could do that, but that's not something that's easy to do. So impulse is equal to change in momentum, and as you kind of learned, these equations can be used as separate equations or they can be connected. So you could use this equation, or you could use impulse as force times time, or you can use change in momentum as mass times change in velocity, or you could use impulse as mass times change in velocity. They're all related. So this right here is one of the key things that we need to keep in mind. So that is probably the heart of this particular chapter is this impulse idea right here. So again, I'm just going to say there are problems that have been attached to Google Classroom. You do not need to print out the problems. Again, solve the problems in your notes notebook. Don't be afraid to do that. Put them in your notes notebook. Show your work there. And probably going to put the answers in Google Sheets a little bit different this time, and probably not multiple choice questions. I'm just going to have you type in your answers. Just going to try to find various ways to hold you somewhat accountable for doing the work and kind of as a quick check for me. And last but not least, you should actually read these pages in your textbook now.